1 second. I'm gonna have to open volume mixer. Oh, that's gonna be annoying. Uh, I'll give it another minute for people to come through. All right, let's go ahead and get started. So, good morning, everybody. It is Monday morning. Well, it's very close to it being afternoon, actually. So glad all of you could make it here. Many of you have turned in most of your assignments, so you're doing exceptionally well in the class. Some of you have yet to turn in the math biography. I know I didn't explicitly say like what it is that you're supposed to do in it, but I think the instructions are fairly clear in terms of like what the expectations are. The math biography is just so that I have more information about who you are as a student, and a little bit of your history and background. Every other day we're gonna have an IXL skill. Many of you have already started doing IXL, and I really want to appreciate you all. Some of you have gone above and beyond and actually gotten a 100% on your IXL. Um, I ended up sending those messages this morning so that your parents could have a good, start of the day, and hopefully we can keep that up. So just a reminder, if you can get a 100% on IXL, I will send a talking points message home. Give me 1 second. I'm trying to mute the audio. Okay. Oh no, that still happened. Let's see if that works. We'll see. But anyways, let's move forward. Today's quote of the day: you only fail when you stop trying. You don't fail if you don't get it right the first time. You fail if you completely stop trying. So when it comes to math or English or history or science or any other particular skill that you do, if you stop trying to achieve it, you're going to end up failing. So my advice to you is Don't stop trying. Even in mathematics, ask for help. Today's learning goals. So we will look at how to determine if a shape is an enlargement or a reduction, right? Whether a shape becomes bigger or smaller. And we will also apply dilations to shapes on a square grid. So we're going to take a shape and we're going to make it bigger. And I'm going to show you how to make it bigger. Some new words today that you might not know what they mean, but we'll get to it, are enlargement and reduction. We do have a vocabulary word. Ray. A ray is a line that goes on forever in one direction. So here it goes on forever. And here it stops. Oh, thank you so much, Avalon. I'm gonna post.
Do I have to write it in a notebook?
Yes, 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 yes. Thank you. Copy this in your notebook.
Do we have to write the array and something like that?
Yes, yes, you're copying this in your notebook.
All of it? And the scale factor too?
You should already have the scale factor actually, so you don't have to do the scale factor.
Let me check if I have the scale factor.
Mhm.
Oh yeah, I have the scale factor.
Beautiful. And then I'm gonna, in the chat box, I'm gonna paste the link for the notes. There you go. In the chat box, I went ahead and typed in the link to the Jamboard session. And we don't have a quiz, we have an exit ticket, but it shows up as a quiz. So on Friday, was it Friday or Thursday? On Thursday, we talked about a scale factor. Remember, you can think of this as your multiplier that makes a shape bigger or smaller. Yes, you do have to copy the definition for array. You don't have to do it for scale factor if you don't want to, since you might already have it. We have two shapes. One is smaller, one is bigger. We want to know if these are dilations of each other. We want to know if the smaller shape was dilated to make the bigger shape. So I want you to ask yourself, take a look at these two sides. What's the scale factor there? Take a look at the red side now. What's the scale?
Wait, where do we write this down? And what's it called? In the note or where?
You don't have to copy this.
Oh.
You don't have to copy this. You just have to think about it. But you can use your notes. So
Okay.
think about what the scale factor is for the blue sides. I think Angel has an idea of what it is. Think about what the scale factor is for the red. So what do you have to multiply so that you can go to 10? And then answer the question, are the scale factors the same? I'm gonna give you 1 minute. You don't have to finish it, okay? I'm gonna give you 1 minute to try to answer these 3 questions. In the chat box, type out your answers if you'd like, but do not press enter. And I know a couple of people already have an idea as to what it might be. Okay. If you have an answer, you can go ahead and type it into the chat box. I'm gonna call on individual students to help me answer this question. Angel, can you unmute yourself and let us know what the scale factor is for the blue sides?
For the blue side, it's 3.
And how did you get 3?
Because I multiplied 3 times 3, so it equals 9.
Perfect. Thank you. Yeah. The scale factor here is 3. Emily, can you please let us know what was the scale factor you got for the red one?
For the red one, it's 2.50.
And how did you get 2.50?
Because 4 times 2.50 equals 10.
Thank you so much, Emily. Because 4 times 2.50 is equal to 10. So the scale factor here is 2.50. You don't have to copy this. You do not have to copy this. So, Edwin, unmute your mic and please let us know, do they have the same scale factor? Edwin? Okay, this is awkward. Ricky, I know your mic is working. Are these 2 scale factors different or the same?
Different.
So does that mean that these 2 shapes are dilations? Sí or no?
No.
You good. You got it. Are the scale factors the same? Heck no, they are not the same. So these two shapes are not dilations. They are not dilations. These are two different shapes. Ooh. So as I said, you don't have to copy this, but it is important that you are listening and actively participating either in your head, through voice, or through actually typing into the chat. I do want to highlight something that Surami said. Surami noticed, hey, we're multiplying by 3 here. So in order for this to be a dilation, this also has to be multiplied by 3. And so she said, if this were to be a 12, it would be a dilation. And she is correct. If this was a 12, it would be a dilation. Are you going to put this meeting on YouTube? Yes. That's why it said, does it say live on YouTube on your camera or on your screen? It does. If y'all actually want to see the, if you want to see the stream right now, it's like 15 seconds late, but if you want to take a look at it later, this is a stream. Yes, Doris, we're streaming this live from YouTube, so you can watch it later. Everybody, if possible, please copy this picture in your notebook. I'll give you about 20 seconds. Yes, you need to copy this. You can copy it on the same page. It doesn't matter. So we have array. Array, remember, it's just a oopsie. It's just a line that goes on forever in one direction. This is A, and this is B. So the distance here between them, you think about it as 1. We want to find and label a point C whose distance is twice of B and A. So we want to find a point on this line where the distance is going to be twice as long from A to B. So somewhere right here on this line, there's a point C where the distance is twice as long. And you are going to help me find that point. I'm going to be doing this, and you're going to tell me when to stop so that the distance is twice as much. I'm going to ask that you unmute your mic and tell me when to stop. Let's go ahead and begin. Tell me when to stop so that the distance is twice as long as A to B.
Stop.
Stop.
Okay, I think there was a lag. Do I need to go back?
Yeah. Stop.
There.
Okay, right here. Okay, this is gonna be difficult. Like
No.
right here?
No. More down.
More down?
Yeah.
So like right here?
No. Yeah, let's see. Let me check. Yeah.
That's pretty good. That's pretty good. So this distance is times 2.
Shut up.
So I think a student is having internet issues. Edgar, if you're having issues, esta lección estará en el internet. You can always find it on YouTube, okay? I'll give you the link in case you're having issues right now. So try to be with us here, but you will get to see it later. So this new point is twice the distance from A to B. Now we're going to do the same thing, except we need to find a point D whose distance is half from A to B. So if this is A to B, we want it to be half the distance. If this is a banana, by the way, we want it to be half, right? Half. It needs Nutella. All right, we're gonna do the same thing. Half the distance from A to B. Tell me when to stop.
Stop.
Right here?
Yeah.
Call this D. That actually looks really good. That looks on point, actually. So this distance is 1/2. So for the first one, the blue one we did, what was your scale factor? How much did we dilate the line by? What was our multiplier?
2.
It was 2. And what about the red one? Not the red one, the green one.
By 1/2.
1/2. Thank you, Ricky. What's the decimal? Does anybody know what the decimal is? Is 1/2?
Yeah.
0.02 or 0.2?
Ooh, close.
0.5.
0.5.
0.5. Yes. You got it. That's why $0.50 is 50 centavos.
Oh.
Okay. This class is doing a lot better than my previous class. Como que todavía estaban dormidos. They were still sleeping. They're all doing good. Don't tell them that. So there's 2 things I want you to copy from this page. Okay. Let me highlight those. Ay Dios. That's not highlighting, that's underlining. Since the scale factor is larger than 1, the point must be farther away. I'm just gonna actually just copy what I highlighted. Actually, let me highlight this better. If your scale factor is bigger than 1, this means it's gonna get larger, which means that the distance will also get larger. What happens if your scale factor is less than 1? Well, any number that is less than 1, if you multiply something by a number less than 1, the value will in fact get smaller, because you're taking less than 100% of the original number. So if you, for example, you know what this is? What is this?
Kit Kat.
It's a Kit Kat. It's a strawberry flavored Kit Kat. I got these in Chinatown. Apparently, I don't know how to open up a Kit Kat. Okay, how many Kit Kats?
2.
So if I eat half of it, how many will I have?
The what?
If I eat half of this, how many Kit Kats will I have left?
0.5.
Ooh, close, close.
No,
Yeah,
no, no.
I will have one Kit Kat, right? So this is multiplying by half. This is what multiplying by half looks like. Amazing. Okay. What happens if I multiply by a half again? How much will I have left? I have
0.5.
0.5. Watch, I'm gonna eat half of it. What happens if I multiply it by a half again? How much will I have now?
2.
0.
No, but I'm only gonna eat half of it.
Oh, 0.5. No, I don't know.
A
What's
half.
What's half of 50 cents?
25.
25 cents. Can I keep taking half of this? I can always take half of it, right?
Let's see. I don't know. I don't know my.
I mean,
Let's
Kathy,
see.
if I can always keep taking half of what I have left, right? I don't have to eat the whole thing. I can be cheap and just keep eating half of it, right?
Yes.
Oh yeah, you can.
I can always keep taking half of it, Raj. Okay, I'm just gonna eat the whole thing. So what happens if I multiply it by a number that's less than 1? The amount gets smaller and smaller and smaller. So when it comes, me tengo que lavar las manos. When it comes to dilations, a dilation with a scale factor less than 1 makes the points closer. When you multiply a number less than 1, it makes the points closer to 0. So please copy those two sentences down. And if y'all were in class, I would definitely give you some Kit Kats. I don't know what that means. I don't know what that means. Anyways, I think I copied this and I pasted it into the chat. Si no, les voy a poner, I'm gonna put the link. Where did you get IG from? I'm gonna type in the chat the link for the Jamboard because I am gonna move forward, okay? Somebody just asked me, do we have to copy this? Yes. Please copy these two images. You can title it IXL notes for October. ¿Qué día soy? El 19. El título, IXL notes for October 19th. I'm gonna give you about 90 seconds to copy these two problems. Okay. So before we begin, I'm gonna ask, I'm gonna ask one brave student to unmute their mic and explain to me what one of these words mean. Who is it gonna be? Well, let's ask for volunteers first. Does anybody wanna take the hit and put yourself on the spotlight? All right, Kelvin, can you please let us know, what do you think the word enlargement means?
Like growing?
Yeah, it means to make bigger, to grow. Yeah, thank you. So enlargement means to make bigger, right? What word do you recognize in that word, enlargement? What word do you already know?
Large?
Yeah, the word large, which means big. So now, can I have another brave volunteer? Okay, somebody other than Kelvin. Somebody else. You can either raise your hand or you can unmute yourself and say me. And you are going to define. All right, awesome. Diana, can you please let us know what you think the word reduction means?
I think it means to go from big to small.
Ooh, to make smaller. Okay. And what word do you see in there that makes you think it means to make smaller?
I think duction.
Duction. Okay. That's actually hilarious. Well, not hilarious. Somebody in my last class also said duction, and I'm like, what does duction mean? And they're like, well, it means to make small. I'm like, I don't. It's not the re. Hold up. I don't know who's a gamer here. But anyways, it's actually the word. It's this word right here. Reduce. Reducir, right? Reduce, it means to make smaller. So, Doris, I see you're typing into the chat. I think you're there. Can you unmute yourself? And let us know. We have this square that's a 2 by 2. And then you apply a dilation and it becomes 8 by 8. Did this shape get bigger or smaller?
It got bigger.
By how much? What's the scale factor? How much are we multiplying it by?
4.
So this is an example of an enlargement where the shape gets bigger. Call on somebody, Doris. Doris?
The
Oh, she's lagging. Oh, okay. Yep. She's lagging, so I can't hear anything she's saying. Okay. How about you type it into the chat? Type out their name. Who do you think, who do you want? I can't speak English right now. What student in the class do you want them to answer the second question? All right, Diana, you got called on. You have been summoned. Diana, in the second image, is this a enlargement or reduction?
It's a reduction
What makes you say it's a reduction?
because you can see that the bigger triangle is pointing, there's like an arrow pointing to a smaller triangle.
Ooh. So this is your original triangle, and this is the dilation, right? The transformation. And then how much did it go down by? Can you tell me what we multiplied or what we divided by?
Let me think for a minute.
Okay. Does anybody think they have an answer? Like how much it multiplied or divided by?
10.
Okay, okay. But did we multiply by 10 or divide by 10?
Divide.
Divide by 10, right? Yeah, yeah. We divided by 10. So we divided by 10. How can I write that as multiplication? I can write this as multiplication. Dividing by 10 is the same thing as multiplying by what? Does anybody know?
10?
Well, if you multiply by 10, it's gonna get bigger. So it has to be, we have to multiply by something less than 1,
Oh,
aka
divided by 10. Wait. is it?
yes, we're dividing by 10, pero how can you what can you multiply so that 30 times this number is equal to 3? We have to multiply by a fraction. What is that fraction though? Ooh, Angel, you're super close. So Angel thought it was 1/3. And that's if you're dividing by 3. If you're dividing by 3, it's the same thing as multiplying by a third. Huh. So if you're dividing, oh, okay. So 1/2 would be dividing by 2. So what if you're dividing by 10? What is a fraction? What do you have to multiply by? Yes, you saw the pattern. 1/10. 1/10, multiplying by 1/10. And notice how the number 1/10 is smaller than 1. It's 10 cents or 1/10. All of this, todo esto, is basically your IXL. This is what you're doing on IXL. Except you're not doing this, you're not finding out the scale factor. All it's asking you is it an enlargement or reduction? Is it getting bigger? Or is it getting smaller? That's your homework for today. And I know a lot of you can definitely get 100%. Are there any questions about this particular page? Okay. This is where things get kind of trippy, a little bit difficult. So we have a shape, rectangle A, B, C, D. We also have a point. We want to make this shape twice as large. Before I do that, who likes to draw graffiti here? Or who likes art here? Okay, a couple of you. So my my first letter of my name is M. There's this technique where if you want to make the letter M 3D, you draw these lines right to the point, and then you just do this. You just connect the lines, and then you can sort of delete everything else. And now I've created this 3-dimensional M. If there was a box here, right? This is approximately making it twice as large, where I start to delete some of these lines here. What we're doing here is exactly what we're gonna be doing here. How many times bigger are we making the shape? 2. And this is where we start. So the first thing you wanna do is you wanna make all these lines first. These are called rays, remember from our vocabulary. So we've drawn out the rays, but now we want to know how far do we have to go so we can make this original rectangle twice as large. Well, let's start with P. Sorry, let's start with A. I start at P, and to go to A, I gotta go this much distance. Alexander, to go from P to A, how much do I have to go up by? Yeah.
I don't know.
Oh, sorry. I thought that was I got somebody in the chat telling me the answer. So Alexander, how much did it go up by? How many little squares do we have here?
Five.
From P to A. From P to A. Right? So from P to A. So right now we're just looking at this by 2. Yeah, sorry. It's kind of difficult to see because it's not showing up on the screen. But we went up by 2. And then Betsy, to go now over here, how much do I have to go to the left?
One.
By 1. So this little triangle that I drew right now, it looks like this. It goes up by 2 and 1 to the left. So I'm gonna do it again. I'm gonna go up by 2, 1 to the left. And this point right here, I'm gonna make it big. That's gonna be my new point A. That's my new point A. I know it looks very crowded. There's a lot of triangles and circles and numbers. Let's do B now. Here's B. We're gonna start at P. Marcos, how high do I have to go so I can get to B? Do I have to go up by 10? Do I go up by 1? How much do I go up? Diana, you do not have to copy this down. I don't think everybody has this graph paper. Marcos, are you there? All right. So can anybody tell me how much I go up? Actually, it might be better if I draw the triangle first. So here's the triangle I want us to draw. That's our triangle. So what's this distance here? How many squares do we have here? Yeah, Maria Jose. This is also 2 up and 5 to the right. So we're gonna draw the same triangle here now. Right, because we want to go up by 2 and 5 to the right. And now this point right here, that's going to be my new B. I know it seems confusing, but it does get easier. For C, here's P, and here's C. Let's draw the triangle. That's my triangle. If I want to go from P to C, are you going to tell somebody to go up by 2? Or are you going to have to go down by 2? Down by 2. So we go down by 2. And how much do I go to the right? How many little squares do I have? Yeah, 5. 5. So if we want to know where on this line do I need to stop, I just draw another triangle with the same sides. I go down by 2 and then 5 to the right. This point right here, that's going to be my C. Last but not least, we got to do D. Here's P, and here's D. My triangle is going to look like this. how much do I go down by? Two squares. It's 2, right? 1, 2. And how much do I go to the left? 1. So we do the same thing. We draw the same triangle again. Down 2, 1 to the left. And this point right here, we're going to call the we found the 4 new points. The distance has been stretched by 2. Let's connect the points. There's a lot of stuff on the paper right now. So I'm going to leave the original one right here. But now this one, I'm going to delete everything. The smaller rectangle has now been doubled to create the bigger rectangle. Eliseo, if we take a look at this rectangle, how much does it measure? The small one. How much does BC measure? Eliseo? Oh, okay. I was kind of hoping you would say it in voice chat. Yeah, 4. Pick on someone, Eliseo.
Leslie.
Leslie, how much does this side measure, the one on the right? Right here. How much does this measure? I want to give you the opportunity, Leslie. I know it's kind of hard to see on the screen. One, 2, 3, 4, 5, 6, 7, 8. So the bigger triangle measures 8. I'm not going to do this one and this one because we know it's going to be true. Our scale factor was 2. And we know that 4 times 2 is equal to 8. So the length was doubled and the width was also doubled. We will have a homework assignment on this tomorrow, how to dilate shapes, but we're going to practice it more tomorrow. This particular problem, it's the same thing. You're doing the same thing. You want to dilate it by a factor of 2. So you want this distance to be the same. You want it to be twice the distance. Oops. Whatever this is, you want it to be twice as much. And you can do this by building the triangles. From T to Q, this is going to be your triangle. Up by 1, 3 to the right. So you create the second triangle. Up by 1, 3 to the right. This new point right here, that's your Q. For R, here's my 2 points. If I draw my triangle, it's going to look like this. I go down by 1 and 4 to the right. Down by 1, 4 to the right. This new point is my R. I apologize if I am lagging. If you go to my stream, if you go to my YouTube stream, you should be able to see and hear what I said. Last but not least, S and T, you draw the triangle. And somebody just asked me, why do you always go up or down first? It's just easier for me. I like to go down, in this case, going down, and then 2 to the right. There's my triangle. I went down by 2, 2 to the right. So we draw the same triangle. Down by 2, 2 to the right. And that's my S. Once you have all 3 points, you connect them. So the bigger triangle is twice as long as the smaller triangle. It should look like a diamond, yes. Before we head out, there is an exit ticket. It's not a quiz. The exit ticket is in the chat box. You will get points based off of if you understood today's learning objectives. You can retake it if you get a score that you don't like. And we do have homework, but I'm not going to post it right now in the chat box. You can find it in what's it called? On Canvas. Brian? No. The homework is IXL. So in the chat box, I typed in what the homework is. It's the IXL. Oh wait, no, that's the quiz. When you are done with your exit ticket, you can go ahead and log off. When you are done with your exit ticket, you can log off. But please do not forget to work on IXL. Have a good one, Mario. And I'll stick around for a couple minutes after class in case anybody has questions. Michelle, you'll be able to do the exit ticket really quickly, honestly, if you do it right now, honestly. If you click on it, it's 3 questions. I think you'll be able to do it really quickly. Surami, yes. Ashley, we don't say goodbye. We say see you later. Thank you, Maria Jose. Let me get my guitar. I left my guitar outside. Awesome, Emily. Congratulations, Brian. You are more than free to go ahead and log out and get a break. You don't get the second question. Oh, the second question is, you have a shape and you are trying to dilate it, okay? I'm not gonna tell you what that means. You're trying to dilate it and it tells you what the scale factor is. If a side length measures, I think 6, right? It says if it measures 6, what happens to the new side length? How long is that side length gonna be?
See you later.
Have a good one. Have a good one, Juan.
Wait, what is the dilation?
Monday?
What is the dilation? So
You know what a dilation is.
I don't know. I forgot.
Wait, you have your notes, don't you?
Let's see.
Look at vocabulary word dilation. What does it say?
Let's see. Let's see. Oh. No factors. It's a with a scale factor less than and what I bring these points closer.
Wait, that was from today. Go check what you wrote on Thursday.
Thursday. Oh. Dilation. Oh, dilation.
A dila-
The transformation that makes a shape bigger or smaller.
Okay.
What is it? Preparation, something like that.
Okay. So so a dilation is when you make something bigger or smaller. Okay. And now are you on question 2?
3.
I don't even remember. Oh, okay. So can a dilation make a shape smaller?
Yeah.
Okay.
Right?
Monday?
Is it right?
I'm not gonna say yes or no.
Come on.
You just told me. Okay, so you told me the definition of a dilation is when you make a shape bigger or smaller.
Oh.
And the question is asking, is it possible for a dilation to be smaller?
Yes.
Okay.
True. Wow.
I'm not gonna say yes or no. Ah. This is difficult.
Hold on a second. I'm at the second question. I don't get it.
Okay, so ¿cuánto mide la línea?
Let's see. 6.
Okay, and what's your scale factor?
3.
Okay, so does that mean the shape is gonna get bigger or smaller?
Oh, let's see. Smaller.
Surami, is it gonna get bigger or smaller?
Bigger.
It's gonna get bigger, Ricky.
Ow.
So it's gonna get bigger. So what do you do with a dilation? What are you gonna do with the two numbers? What do you have to do?
Multiply? No. Yeah. Divide?
I'm not gonna say yes or no, but I think you should trust yourself with the first answer you gave me.
Multiply. Okay, let's see. Multiply.
Edgar, déjame fijarme lo que estás hablando de. What are you de lo que hablas? Para pa 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 pam para pam pa pam para bailar la bamba. Oh, nice, Edgar.
to be. I don't know, man.
Yeah, you're good. Edgar, estás bien. You're good. What's up, Ricky?
I don't get it. I still don't. Number 2.
Okay, let's go back to you're taking notes today in class, right?
Yeah.
Okay, let's go back to a ver. So let me go back. Okay, let's take a look at this. So the original length of this rectangle era 4. And what was your scale factor?
So what you call 3? Oh, 2.
2. And what did we do with the 4 and the 2 to get the new side length? What do you do with the two numbers?
Multiply.
And so what's 4 times 2?
8.
Okay. It's the same problem with you, except this is not a 4. It's a 6. And what's your scale factor?
3.
So what are you gonna do with those two numbers?
Multiply.
Yeah, Edgar, tú vas bien. You're good. You're good. Que
Oh,
no se
I
te,
got a 3 out of 3.
que no se te olvide hacer la tarea de IXL, ¿ok, Edgar?
Okay.
I'm done.
Good?
Yeah.
¿Está en Canvas?
En Gamas. Oh, yeah, Canvas. Yeah, Canvas. Yeah, está ahí escrito. Es IXL, so recuerda de when you log in, de que te metas con tu Google account, okay?
Okay.
Oh, okay. I can leave now.
Just don't forget to work on IXL, okay?
Oh, okay.
All right, Ricky, thank you so much for staying after, all right?
Okay.
¿Cómo se llama otra canción? Michelle, are you still there? Or are you even home? I don't even think you're there. You might be doing other things. Well, Surami, do you have a question or are you good in the hood? No, don't say bye-bye. Say see you later. Do you have any questions, Michelle, or are you good? Órale, se cuidan.